Say you have an application, maybe a web app. When you first started, it consumes a bit of RAM. Several hours later, perhaps under a certain load profile, that same app is now consuming several gigs of RAM, maybe a lot more than it should. You have a memory leak. Maybe something is hanging on your connections, or you have some objects that aren't being correctly released. A common step might be to use a profiler to try to understand where your memory is being used, where it's being held onto. Maybe you'll load it into a test environment, take a heap dump, analyze it, fix it, and then deploy it. Sound familiar? You can probably guess the next part because black swans happen. Sometimes certain load profiles just don't happen the same way in a production use case. In our Kubernetes, too, the continuation gets stronger and stronger. What you see in your lower environment may not be the reality of what's in production. So what you really need to do is profile in production. But that's much more resource heavy and invasive to do, right? What if you could? What if you could profile your application and have that information in your observability stack? What if you could see sampled set of your app profile in Grafana? You can correlate it across deployments for your clusters and see all of your cloud native infrastructure. What would it mean to understanding how your app performs in that environment? Hi, my name is Wes Reisz. I'm a tech principal with ThoughtWorks and host of the InfoQ podcast. In addition, I chair a software conference called QCon that happens in October in the Bay Area. You can check us out at QCon SF to learn more about the conference. Today on the podcast, I'm speaking with Frederic Branczyk,
who, incidentally, will be one of the presenters, along with Justin Cormack of Docker, Joe Duffy of Pulumi, Marcel van Luijsen of Q and Google's Borg fame, in Carmen Anda's Language of Infrastructure track at that very conference. This Language of Infra track is just one of the 15 tracks at this year's conference. It's not too late to join us at QCon. But back to Frederic.
He is the CEO and co-founder of PolarSignals. Before founding PolarSignals, he was a senior principal engineer and the main architect for all things observability at Red Hat, where he joined through the CoreOS acquisition. Frederic is a Prometheus and Thanos maintainer, as well as the tech lead for the special interest group for instrumentation in Kubernetes. In late 2021, PolarSignals, in addition to closing a $4 million seed round from GV, formerly Google Ventures and Lightspeed, open source Parca, an eBPF-based continuous profiler. Today on the podcast, we're speaking with Frederic about Parca. Now, continuous profiling is not only possible, but happening. Frederic, welcome to the podcast.
Thanks for having me.
So I remember a KubeCon EU in Barcelona. It was just before the pandemic, so 2019, I think. You and Tom Wilkes did a keynote where the two of you talked, at least in part, about continuous profiling. Is that where Parca came from? I mean, is that the origin story?
I think that was kind of the turning point for me to think that this is something we really need to explore really deeply. And I think that's what ultimately made me think I can start a company around this. But there's a longer backstory to this that kind of led to why Tom and I were even allowed to kind of do that keynote to talk about, in part, continuous profiling. That entire keynote was about more broadly, what does the future hold for observability? And continuous profiling was one of the three predictions that we were making in that keynote. But really what led to that point in 2019 was kind of ultimately the beginning of all this is me joining CoreOS in 2016. And at that point, for those who maybe don't know, at this point it's history and we've got always new generations of engineers joining. So CoreOS was kind of one of the first Kubernetes companies. And even before CoreOS went into the Kubernetes space, we started with this mantra of always automatically upgrading server software because CoreOS's mission was to secure the internet. And the biggest impact we felt we were going to have was by automating updates, because it wasn't that security problems weren't being fixed, is that people aren't updating their software. And this is still a problem today. And the way I came in was just after CoreOS did the Kubernetes pivot, we kind of realized that all of this automatic updating is really nice, but if the software isn't actually doing what it's supposed to be doing, kind of before, during, and after upgrades, then automatically upgrading isn't all that useful either. When I came in, everything in my responsibility was all about monitoring with Prometheus. So I came in and kind of started creating a Prometheus setup for our product, and that ultimately evolved into what is today known as the Prometheus operator. Kind of a glimpse of history also, this was one of the two very first operators ever created, right? Today we have hundreds and maybe thousands of operators out there, right? This was genuinely one of the two operators that were part of the original announcement. And Yeah, I became a Prometheus maintainer, and through that ultimately also became, like you said, technical lead for instrumentation in Kubernetes, because kind of everything in that intersection was what I was working on, right? To this day, I'm still maintainer for the Kubernetes integrations in Prometheus, and relatively recently, I actually stepped down from my position as tech lead in Kubernetes just to have some more time to spend on some other things. But ultimately, all of this, and then after the Chorus acquisition in 2018, I stuck around at Red Hat. Red Hat acquired Chorus, and like you said, I kind of became architect for all things observability. And in 2018 was when I read this paper that Google had published about how they are profiling all of the data centers all the time. And this was super interesting to me for kind of two reasons, right? One, I wanted all the capabilities that they were talking about in this white paper. They were talking about how they always have the performance data available when they need it. They never need to kind of manually profile their code. And they're able to cut down on infrastructure cost by multiple percentage points every quarter consistently, right? All of these were extremely exciting to me because as someone who works in infrastructure, my customers have that unrealistic expectation that everything uses zero resources and has zero latency. Anyone who works in infrastructure knows this. This is kind of the same expectation we have towards databases. It's the same expectation we have towards Kubernetes and Prometheus themselves. And so all of this, and then my kind of experience with Prometheus and the Prometheus storage and all of these things, I felt like I was in the position to actually create something. And that is ultimately what led to that keynote. I put together this really barely compiling proof of concept, put it on GitHub, and Brian Lyles was super, super nice to invite me to speak in that keynote on that topic. So yeah, and then ultimately, like I said, through that keynote, I think I realized that there's something bigger here, right? The continuous profiling market really wasn't established at all. There was not a single product on the market for this, but all the hyperscalers were doing it. Google was doing it, Facebook was doing it, Netflix has tools similar to this. So this makes sense. And so end of 2020, I think I was kind of similar to a lot of people where, it's been 6 months into COVID, people feel relatively uninspired. And I felt like there was this opportunity, right? And I felt like it was now or never. And then that's when I decided to start the company all around this.
That's awesome. So let's back up a minute and talk about continuous profiling. I gave that little example in the beginning of having like a memory leak. What does continuous profiling mean in practice?
Yeah, so continuous profiling, like you said earlier, just the profiling part, right, is as old as kind of software engineering gets. We always needed to understand where our resources are being spent. And profiling allows us to do this kind of down to the line number. And we can associate where is my CPU time being spent, where are my allocations happening, where is memory being held. And we can do this down to the line number. But historically, profiling was always associated with having a lot of overhead. So that was kind of what prevented us from doing this in production all the time. And the way that the kind of hyperscalers solved this is in part by actually building these collection mechanisms into their operating systems. And I don't know about you, but I don't know a whole lot of companies who maintain their own operating systems to be able to do something like that. And so it was kind of also just doing like me looking at this problem at the right time, because eBPF was just starting to kind of gain momentum. And eBPF is exactly the technology that it allows us to kind of replicate what the hyperscalers were doing ourselves, and not having to maintain custom operating systems to do this kind of thing. So continuous profiling essentially is that we always profile in production all the time, throughout time, right? Our entire data center, every single process. And like I said, there are two main contributors why we can do this in production. One, eBPF just kind of allows us to grab exactly the data that we need in exactly the format that we need. So we basically copy a bunch of memory addresses from the kernel into user space, and that's it. So this is super, super lightweight in terms of what even needs to be done. And then the other aspect of it is, because we're doing this all the time, we can do profiling at a relatively low frequency. So the way you can kind of imagine how profilers work is that they look at the quote unquote current stack trace, let's say 100 times per second. And based on the stacks that we collect whenever we do this, we can build statistics of in which functions of my program is time being spent. So that's essentially how CPU profilers work. And if you do this at a relatively low frequency, let's say 100 times per second, then the granularity is not extremely high. But because we're always doing this throughout all of time, we're actually statistically still getting all significant data. And so there's actually a little bit more to continuous profiling than just doing profiling all the time, right? It all of a sudden allows us to do completely new things that we couldn't do before. Like CPU profiles, all of a sudden we don't have just a glimpse of like a 10-second period where we happen to catch the process, recording it throughout all of time. And we can look at all of this CPU time in a report where we look at the entire process's lifetime, for example, right? And this is much more representative also than the 10 seconds that we happen to look at, right? Did the users happen to do this one thing that we're interested in those 10 seconds, right? Or, software is kind of unpredictable, and that's why we need monitoring and observability in place so that we can reason about what has happened in the past. And continuous profiling is essentially another aspect of observability. It shines another light on our running applications.
So, nothing's for free, right? You say it's lightweight, but what does it actually cost to run continuous profiling in production with the tool? We haven't talked about Parca yet, but using, say, Parca, what does it actually cost to run it in production?
The cost is essentially, we find it's somewhere around 1 to 3% in overhead. It can kind of depend on, you can tweak the sampling ratio a little bit, and it depends a little bit on the workload. But most setups we find is around the 1% mark.
But for that investment, you get a profile of not just your machine, right? Like all of your infrastructure that this is running on.
All of your infrastructure, exactly.
So talk a little bit more about that. So like we can run perf on machine and get some idea of like an individual Linux kernel of what's happening. But how does this continuous profiling work for like a cloud native ecosystem?
The open source project that we created called Parca, P-A-R-C-A, it kind of ships with two components. The agent, this is the thing in, let's say, a Kubernetes environment, you deploy on every node using a daemon set. And then there's a central server where all of the agents send the sampling data that they collect to. And then the server is the thing that you can use to kind of query and analyze this data. Yeah, so that's kind of the setup. And because of our history, we're super close to the Prometheus ecosystem, super close to the Kubernetes ecosystem. So we very intentionally engineered this towards Kubernetes environments as well. That doesn't mean that it doesn't work in other environments, but the integration is particularly good in Kubernetes environments.
Okay, so you use a daemon set, you deploy out to nodes, and then you have visibility of then like everything that's happening in that node. Like what about the pods that are running in there and the containers that are within the pods? Do you have visibility into what's happening there?
That's right. I can talk a little bit about how it works today because we're slightly changing it, but this is not ready. But I can talk about that already because I think it's pretty exciting. The way it works today is that we discover all of the containers on a host and then automatically profile all of those containers.
At the networking level or at the kernel level inside the container?
I guess both. So we look at each individual process in all containers. And so we do see the user space stack. So, the code that we typically write, but you also see the kernel space stack actually, which is something that's pretty unique with Parca actually. With a lot of profilers, you only get to see the CPU time that's spent in your user space code. So you only see, you're reading a file, right? Or you're allocating some memory, but you're not seeing that this is causing a page fault in the kernel or something like that, right? This can be extremely valuable information in order to improve performance of your software. But to get back to that, in the Kubernetes case, we label all of the data that we collect in a very similar way as you're probably used to from Prometheus. There's the connection to our past again, where we kind of add labels for the namespace, the pod, the container, all of these things, so that you can kind of slice and dice the data however it's useful to you, right? If you already know there's this one particular workload that you want to optimize, you kind of just filter all of the data by this one, let's say, container label, right? I don't know, my web app, right? And then you'll only see the CPU time spent by your web app. And you can kind of dive deeper into specifically that. But one extremely powerful thing, and this is one of those things that continuous profiling is required in order to do something like this, because we're continuously profiling our entire infrastructure, we can actually merge all of this data into one report, right? And we get a single icicle graph or flame graph for our entire infrastructure. And this is super powerful because we're not just looking at a single process, we're looking at the CPU time spent in our entire infrastructure. And this often shows really, really surprising users of CPU time or allocations in the infrastructure, because it's also, often maybe we don't recognize that there's only one instance of this type of application, right? But we have hundreds of instances of this other one. And we, optimize this other one that is kind of insignificant in total. Or there's a single line of code that is poorly allocating memory. We keep seeing these things over and over, that it's very simple things where maybe we didn't know, because we shouldn't do premature optimizations, right? We should base performance improvements on profiling data. And so we see this often, that there are pretty, let's say, naive things that we can improve that really only need this data. And historically, it was pretty difficult to get this data from production environments. And this is kind of what continuous profiling is intended to kind of democratize.
Yeah, that's awesome. That's awesome. What kind of use cases and stories are out there of folks that are using Parca continuous profiling? What are you hearing from folks that have implemented it?
I think we're seeing three main use cases. So the first one is one that I sort of already touched on. And this is the one that the Google white paper also mentioned, which is purely, it's kind of a data problem. If you don't know where CPU time is being spent, it's really hard to do something useful and effective about it, right? And all of a sudden, when you have this data, we see that most organizations can easily cut down their CPU time by 10, 20, 30%. In the most extreme case, we've seen 55% by a single incorrectly configured application. It wasn't even that, the code was wrong. It was that this was poorly configured. And the user just didn't know that 55% of their CPU time was being spent in this thing.
Yeah, and it probably was perfectly configured where it was tested with a profiler in a lower environment, right?
Exactly. Yeah. So that's kind of the number one use case. Everybody wants to save money, right? Especially now, with the economic situation, companies are even more trying to look at optimizing their cloud builds. So that's kind of cost savings. The second one we find is actually an even bigger motivator to use this type of technology. It's companies that have some sort of competitive advantage or, business advantage by having a more performant system. And the really classic one here are e-commerce companies. Like, there's lots of literature around this, but the faster a website is, for example, the more likely we as humans are going to purchase something on that website. And so for e-commerce style companies, it's actually an incentive to have faster software, because it means that they will make more money, right? Making more money tends to be even a higher motivator for companies to do something than cost savings. But, there are more simple cases for this as well. Infrastructure companies, or the kind of classic performance type companies, are high frequency trading companies, right? Where every CPU cycle that you save, you have a competitive advantage to your competitors. I think you can broadly talk about this as just performance improvements, right? But that's kind of the motivation that we're seeing, where the motivation for this is coming from. And the third one is we categorize it as incident response. Essentially, like I was talking about earlier, because of how CPU profiling works, we essentially look 100 times, let's say, per second at what is the current function being executed. Well, this also tells us, in a way, something that is extremely unique to continuous profiling, which is often when we look at a past incident, we're asking ourselves, what was my program doing at this point in time, right? Like, maybe there's a CPU spike, maybe there's a latency spike, or some other indicator that something funky was going on. And CPU profiling data actually tells us what was the code that was being executed, right? It's sampled, but it's still significant because the code that's executed or spending more time statistically will show up more significantly. So it's a super unique tool. And we've built some specific features actually into Parca where you can actually select 2 points in time or even 2 time ranges over time and say, tell me what was the difference between these 2 points in time. And this is extremely powerful. You talked about memory leaks earlier, right? And with memory leaks, it was so amazing to see the first time we got this to work. You kind of just see the memory growing over time, right? And you pull up the compare view and you select a low point and you select a high point, and it tells you exactly the difference and where more memory has been allocated, right? And it's just, you can see it at a glance. Before it was like, you go and maybe you manage to hit your application at the right time to grab a memory profile, right? But here it's really just a click away, a search away. And that's extremely powerful.
When you say you can select 2 points, is there a tool that you're talking, or is this just in like Grafana that you're actually selecting? You talked about the agent and the server. Where are you selecting this at?
The server actually has its own storage. So I was talking about earlier that the Parca agent is kind of the thing that just collects data on each of your Kubernetes nodes, let's say. And then centrally, you deploy a Parca server. And this has its own database and everything. And so that is also the thing that where we ship a UI with. So the Parca server is essentially the equivalent to the Prometheus world. A Prometheus, right? It's this really, really simple to run statically linked binary that has its own database. Everything's built in. You just launch the binary and everything's there. So it ships with the UI, and that's the UI that I was talking about.
And so Parca itself is both the agent and the server?
That's right. Parca is the umbrella project, and then we have the Parca server and the Parca agent as part of that.
And both are open source?
Both are open source.
Awesome. I know you did some interesting things in that database that you were talking. You want to talk a bit about your database?
Absolutely. We tried for a really long time not to build a database.
Like every observability company?
But it turns out, we wanted to be able to deliver exactly that Prometheus-esque experience where we label the data and you can add arbitrary infrastructure labels to your data. However you organize your infrastructure, we don't want to force you into a specific labeling scheme or whatever, right? It's your infrastructure. You should be able to decide how you organize your infrastructure. And so the thing that we found that no other database allows us to do is to essentially dynamically create new columns when we see a label for the first time. The database that we created is a columnar database. And so the difference to the classic relational databases like MySQL or Postgres, they're row-based. So that means the physical unit of how data is being stored is all the values of a single row are kind of physically co-located to each other. In a columnar database, that's different. Actually, all the values of all rows of a column are all stored consecutively. And this is extremely powerful for analytical type workloads because you can load only the columns that you need. And because they're all physically co-located, you can scan and process them extremely efficiently. And there's a lot of things that you can then do to make that processing really, really efficient, like vectorized instructions and stuff like that. But all the columnar databases that we found out there didn't allow us to dynamically create these new columns when we see a new label. And so we tried things out a little bit, but ultimately we just decided we've got to build something new because everything else wasn't going to cut it. The one database that sort of comes close to what we imagined is InfluxDB's new database called InfluxDB IOX. We did talk to the CTO of InfluxDB and several engineers at InfluxDB because we didn't want to build a database, but they were extremely nice and shared all of their experiences building this database. But at the end of the day, basically, we came to the conclusion we weren't going to be able to use their database in time. So we needed to build something ourselves. So after a couple of months of development, we open sourced FrostDB. Actually, originally it was called ArcticDB, but because of naming difficulties, someone actually held the trademark on that name. We needed to rename it. So now it's FrostDB for good.
One of the true hard things in software, naming something, right?
Exactly.
So earlier you said the way Parca works today versus the way it's going to work. I'm assuming that's some of the exciting new stuff. What is that all about?
Yeah, so like I was saying earlier, the way that we collect data today is we discover all of the containers on a host in the Kubernetes cluster, and we start to profile those. The problem with that is that's actually not the entire picture of a host. There are more things running on a machine than just the Kubernetes containers. At the very least, you've got to have a Kubernetes kubelet, right? But probably you'll have a bunch of other daemons. I don't know, maybe cronid for like time synchronization, systemd, all of these things. They probably run on your machine as well. They probably also use some CPU. And so we're actually changing this architecture to profile truly the entire host. And it kind of turns around where we'll still attach the same kind of metadata as we're doing that today. But as opposed to discovering containers using that metadata, essentially, we're just recording CPU time from all processes. And then once we've done that, we then discover the metadata from Kubernetes using the process ID, basically. So ultimately, it'll be everything we have today and more visibility.
Is that different? Is it going to be installed directly as an agent on the host and not a daemon set into the cluster? Will the architecture change?
The architecture will be exactly the same. It's basically just an internal code change.
Tell me, how's the community? Was it October, November of 2021? So been about a year now. What's your community look like? How's that growing?
It's been growing like crazy, actually. It's been really cool to see companies using this technology, companies, actually benefiting in the way that we set out for the project to do that, right? Like sometimes that doesn't happen, right? Sometimes you're just wrong with your hypothesis. So it's super cool to see companies picking up this technology and kind of just running with it. And the most exciting thing is when people do something that you didn't necessarily anticipate. One of the things that we did really intentionally with Parca is that everything's API first and everything's really API driven. So we try to keep our UI as simple as possible so that alternative things can be built around it, right? We want to build a community so that people can build CI tooling around this, for example, right? Like maybe you want to compare previous benchmarking data with this new benchmarking data. World is your oyster is kind of the idea. And so we're actually talking with a couple of folks at Grafana to build a Grafana plugin so that actually all of this stuff can be integrated into your probably existing observability tooling, right? So that's super exciting.
I'm curious about, you have a tool at the server so that you can do these correlations. You also have like an existing observability stack that has all of this other data that's in it. How do you bring them together?
Yeah, so this is another thing where we were really intentional about making this complement really well together with an existing Prometheus setup, right? Basically, the data model is identical to Prometheus. And so if you label your data identically, which because the configurations are exactly the same, to the point where, we didn't just design them in a similar way, we're actually literally reusing Prometheus code for configuration. So for most setups, you can copy and paste a lot of the configuration. But yeah, it's absolutely a complementary thing, right? Like I said earlier, continuous profiling shines a different light on another aspect of your running applications. It doesn't replace metrics, it doesn't replace logs, it doesn't replace tracing, but the kind of detail that you get from continuous profiling, you get from none of the other observability signals. So it's absolutely complementary and you should be using all of them. But exactly that's also why we're excited about Grafana integration, because that actually, allows us to weave it into what people probably already have set up.
Yeah, it's really cool. It's really cool. So what's next for PolarSignals?
Yeah, so PolarSignals, we're actually working, I guess this is kind of unsurprising, we're working on a cloud product for all of this so that you don't have to run the Parca server at all. And yeah, we've been working on that really hard. I think we'll get there by the end of the year that people can start to use that. The idea is there essentially that you don't have to run the Parca server at all anymore. And the only thing you do is deploy the Parca agent in your infrastructure, and it'll all just kind of magically happen by itself.
Awesome. Well, Frederic, thank you for joining us on the InfoQ podcast.
Thanks for having me.
Hey folks, our upcoming international QCon software conferences are starting to take shape. We're back in San Francisco this October 24th through 28th, online November 29th through December 9th, and in London in 2023 from March 27th through 29th. At QCon, you'll find practical inspiration and best practices on how to implement emerging software trends directly from senior software developers at innovator early adopter companies. They'll help you adopt the right patterns and practices moving forward. Learn more at qconferences.com. See you there.